Welcome dear students to today's session of Summit for Maths. Subscribe to the channel and press the bell icon for further notifications. Let's get started. In today's session, we are going to see few more problems on type 6 integration. Here we have a problem e to the power of x into 1 plus x log of x into e power x. Let us substitute t as x into e to the power of x. So we get dt is equal to, we are differentiating in UV method. UV is equal to UV dash plus VU dash. So we get the differentiation as x into e to the power of x plus e to the power of x into 1 into dx. Bringing out e to the power of x common outside, we get e to the power of x into x plus 1 into dx. Substituting these values in the integral I, we get I is equal to integral of log t into dt. This can be integrated using ILATE. So u should be considered as log t and dv is equal to dt. We get du is equal to 1 by t into dt. Integral of dv will give v is equal to t. Using integration by parts, we get integral of u dv is equal to uv minus integral v du. So I is equal to u is log t into v is t minus integral of t into 1 by t dt. T gets cancelled in the integral part. The answer will be log t into t minus integral of dt will give you t plus c. In the next step, we can bring out t outside the first two terms. So we get t into log t minus 1 plus c. Resubstituting the values of t here, x into e to the power of x into log x into e to the power of x minus 1 plus c will be the final answer. The next problem for today's session is 1 by x into x squared plus 1. Let us split this fraction into partial fractions. A by x plus bx plus c by x squared plus 1 into dx. In order to find a, b and c, we consider the LCM part on the right hand side and equate it to the numerator. So we get a into x squared plus 1 plus bx plus c into x is equal to 1. Let us substitute x is equal to 0. So we get a into 1 plus b into 0 is equal to 1, which gives a is equal to 1. We need to find b and c. So let us substitute x is equal to 1 in the above equation. So we get 1 is equal to a into 2 plus b plus c. We know that a is equal to 1. So b plus c is equal to 1 minus 2, which is equal to minus 1. So b plus c is equal to minus 1. Now let us substitute x is equal to minus 1 in the above equation, which gives b minus c is equal to minus 1. Solving these two equations, b plus c is equal to minus 1 and b minus c is equal to minus 1, we can get the value of b. B is equal to minus 2. So b is equal to minus 1. Now let us substitute b is equal to minus 1 in the equation b minus c is equal to minus 1. So we get c is equal to 0. Now we have found the values of a, b and c. Let us substitute in I. So we get I is equal to integral of 1 by x plus minus 1x by x squared plus 1 into dx. So the next step will be integral of 1 by x into dx. Let us separate the fractions. Minus x by x squared plus 1 into dx. The first part will become log of mod x minus, here we have to multiply and divide it by 2 in order to integrate. So half can be brought out and 2 in the numerator will get multiplied with x, and 2x by x squared plus 1 into dx. Now let us make a substitution here. T is equal to x squared plus 1. So dt is equal to 2x into dx. Integral of 2x by x squared plus 1 dx is equal to integral of dt by t, which gives us log of t plus c. So we get the final answer as log x minus half into log of x squared plus 1 within modulus plus c. The next problem for today's session is integral of e to the power of x into 1 by x squared minus 2 by x cube into dx. Here let the function f of x be 1 by x squared, that is x to the power of minus 2. Then f dash of x will be minus 2 into x to the power of minus 3, which can also be written as minus 2 by x cube into dx. This is of the form integral of e to the power of x into f of x plus f dash of x into dx. Integration of this type will give you e to the power of x into f of x plus c. So we get I is equal to e to the power of x into 1 by x squared, which is f of x plus c, which can be written as e to the power of x by x squared plus c. So that's the final answer. The next problem for today's session is e to the power of x into modulus of x minus 1 by x plus 1 the whole to the power of 3 into dx. Now let us add and subtract 1 in the numerator in order to bring to the form x plus 1. In the next step, we'll get e to the power of x into x plus 1 by x plus 1 the whole cube. Minus 1 and minus 1 will add up to give minus 2 by x plus 1 the whole cube into dx. The next step will give e to the power of x into 1 by x plus 1 the whole squared minus 2 by x plus 1 the whole cube into dx. From the previous problem, we can see that this is also of the form I is equal to integral of e to the power of x into f of x plus f dash of x into dx, where f of x is equal to 1 by x plus 1 the whole square and f dash of x is equal to minus 2 by x plus 1 the whole cube into dx. So the result of this integral is e to the power of x into f of x plus c. So we get the final answer as e to the power of x into 1 by x plus 1 the whole square plus c. Let us see one more problem for today's session. E to the power of 3x into 3x minus 1 by 9x squared. In the next step, let us write this as e to the power of 3x into 3x by 9x squared minus 1 by 9x squared into dx. Let us bring 1 by 9 as a common factor outside. So we get 1 by 9 into integral of e to the power of 3x into 3 by x, here x and x square gets cancelled, minus 1 by x squared into dx. Here f of x is equal to 1 by x, so f dash of x is equal to minus 1 by x squared into dx. So this integration is of the type integral of e to the power of ax into a f of x plus f dash of x into dx, which will give you e to the power of ax into f of x plus c. Here a is equal to 3. We get the value of I as 1 by 9 into e to the power of 3x into 1 by x plus c, which can be written as e to the power of 3x by 9x plus c. This is the final answer. Hope this session was interesting. For much more, please subscribe to the channel. Thank you.